This is going to be the first part of lesson 25. I'm going to break this up into probably 3, maybe 4 separate shorter videos. And so chapter 25 is about multiple equilibriums. And so one of the multiple equilibriums is going to be pH and solubility. So when an insoluble acid or base is dissolved in water, the adjustment of the solution, pH, will determine the solubility. So for example, if I take something like magnesium hydroxide, which is considered an insoluble acid or base, it's going to dissociate to some degree into magnesium 2 plus and hydroxide. So how would pH affect the solubility? Well, if I add a base, it's going to have a common ion, right? It's going to have OH in common. So this is going to increase the concentration of OH, which according to Le Chatelier's principle will shift the reaction to the left. This makes the MgOH2 less soluble. If I add an acid, you might guess the opposite is going to occur. And you're right, because I'm adding an acid, which is a proton source. It's going to consume the OH, which essentially decreases the OH concentration, and the opposite is going to happen. The reaction is going to shift right to produce more OH because some of it was consumed, and this is going to make it appear that MgOH is more soluble. There's a YouTube video here if you'd like to watch something else, visual demonstration. There is one right there. So this question says, what is the minimum pH? So we're looking for this value so that we can plug in to the negative log of which chromium hydroxide will precipitate, so solid. Gives me a KSP, so I should be thinking of a solubility expression like we did in the previous lesson. Got to make sure it's nice and balanced. I'm going to set up my ice table because essentially what I'm looking for is pH, and I know that if I can solve for OH, I can easily solve for pH. I'm going to start out with none of my product. Therefore, the reaction is going to shift to the right to produce X amount of chromium, 3 times X amount of hydroxide. You could also put S's here. They mean the same thing. We solve for them the same way. So either would be suitable. Remember, I plus C equals E. So now I have my E values. I have my KSP. And now I'm going to plug everything in. Remember, there's no denominator here because chromium hydroxide is a solid, so its activity is 1. My KSP value in the problem is 6.7 times 10 to the negative 31. It is a very small number. We are going to cube the 3 and the x, so 3 cubed is not 9, it is 27 x cubed. So this is going to leave me with 6.70 times 10 to the negative 31, 27 x to the 4th. So remember when we had 1 to 1, it was always s squared. When it was 1 to 2, we had 4s cubed. When it's 1 to 3, it's always going to be 4s to the 4th. To solve for this, we're going to divide out by 27, and then we're going to take the 4th root of both sides, and that's going to leave me with the value of x, or s, is 1.26 times 10 to the negative 8th molarity. But remember, I need to go back in and plug this in, which is that the OH concentration is 3 times X, where X is equal to 1.26 times 10 to the negative 8th. Doesn't seem like that will make that big of a difference, but unfortunately, it can make enough of a difference to give you the wrong answer. And you know those types of questions are usually what will show up on the test. We're going to plug that back in to the negative log of, gives us a POH as 7.46. pH is equal to 14 minus 7.42, and that's going to give me a pH of 6.58. Okay, so that's the pH at which chromium hydroxide will begin to precipitate as a solid. Okay. All right. On the next video, we're going to do 25 Part B, Lesson 25, which is complex ion equilibrium, and then we'll break the last couple of problems maybe into some separate ones, separate videos.